Okay, so the next chapter that we're going to look at is a chapter called sequences. So I'm going to kind of give you a rundown of a lot of terminology here, just kind of getting used to what it means to be a sequence. You are definitely looking at some kind of an assessment this Friday. So let's start us off here. So the chapter is called sequences. So what does it mean to be a sequence? So our first definition there, we can see that a sequence is just a set of numbers that are in a specific order. So we're looking at, different number patterns. And like I said, it's just an arrangement of numbers that are kind of arranged specifically in an order for a reason, okay? The numbers in a sequence are referred to as terms, okay? So whatever, numbers are consisting and making up this pattern, the numbers that are actually in the sequence is referred to as a term. And then lastly, one thing that's going to be important especially when we start writing equations for these guys in the next couple of days, sequences start with term number one, okay? And one way to kind of think about this is sequences are like counting numbers. If you were to count the amount of students in a classroom, right, you would count the first person being student number one. You wouldn't say that's student 0 or that's student number 4, right? You would count and say that's student 1, that's student 2, and kind of so forth. So if we look at my purple list of numbers there, these numbers are in a specific order, okay? We got 7, 12, 17, 22. These kind of blanks here, I'm just referring to as, there's continuous numbers, and we're going to be able to find these next numbers, okay? As we can kind of look, there is a pattern to these numbers, right? And one thing I was referring to with earlier, with your counting numbers, so this 7 would be term 1. This 12 would be term 2, term 3, term 4, right? And kind of so forth, okay? Sorry, my camera's... Okay, because here in the next couple of days, I'm going to give you a sequence and I'm going to say, find term 7. Or what would be term 4, right? So as we can look, term 4 we would say would be 22, right? We can see it right there. Kind of in more terminology, when we say term number, that is denoted with an N, the number of the sequence, okay? So N is referred to as the number of the sequence, and the number in the sequence, these are usually referred to with A sub N, okay? So it's usually... we just call the sequence A. Okay, the first sequence we see here, we'll call it A, and sub N, meaning, what number of the term. Okay, so the number in the sequence is A sub N. The N actually refers to the number of the sequence. All right, so we're going to look at two patterns. Oh, we didn't even finish this guy. So if we look at this guy, maybe we kind of see it already here. There is a specific pattern as we go from 7 to 12. We should see that we added 5. We added 5. Right, so these are in a specific order. It looks like the difference between them, it looks like we're consistently adding 5. So the next number would be 27. And then, 32? Okay, so again, a sequence is a specific arrangement of numbers there. So we're going to look at two specific types of arrangements. These numbers can kind of go up by, we could have been multiplying by 4. We could have, squaring our numbers. There's a different variety of things that in patterns and stuff that we could look at. But two specific patterns that we're going to look at. Okay, the first pattern is called an arithmetic. No, it is not arithmetic. It is an arithmetic sequence. Okay, and arithmetic sequences can be identified by having a common difference. Okay, and what I mean by a common difference is we are consistently adding, and we're going to look at some examples where we're subtracting as well, where we're consistently adding or subtracting by the same number. Okay, we're consistently adding or subtracting by that same number over and over and over and over again. This is what's going to produce an arithmetic sequence. In the last example we actually looked at, where we're consistently adding that 5, this sequence actually would be referred to as an arithmetic sequence. It has a constant rate of change. Well, we actually looked at something earlier in this year that has a constant rate of change. And hopefully when you hear the word constant, your mind kind of refers to a linear function. Right? Remember referring to and doing a lot of stuff with slope, okay, our linear functions that has that constant rate of change, increasing or decreasing by the same amount every single time. Well, an arithmetic sequence kind of does the same thing here, okay? It's adding or subtracting by that same number every single time, which in return, if we were to go to plot these things, I'm not too interested in the graph this week, but it would produce kind of a nice dotted straight line there. All right, so let's look at some. I've got 4 examples here, and then you'll see another video where we talk about the other sequence we're going to see this week. Okay, so first example, we see a pattern of numbers from 4, 7, 10 to 13. Our job today is going to be able to recognize, is this an arithmetic sequence, and can we kind of extend the pattern here? So maybe we can eyeball this a little bit. I can see that, we're adding 3 every single time. So if we're adding 3 every single time, it looks like this is probably going to be a 16. That's going to go to a 19. Okay, maybe the next example here. Okay, so maybe you can see that the numbers are getting smaller. Okay, so the common difference here should be a negative. Okay, so it looks like here we would be adding a -2. We're adding a -2, adding a -2, right? So I want you to think of terms of a difference here. I want you to think of terms of, we're finding a common difference, but I always want you to think adding. Don't think subtract 2, think adding a -2. Okay, so if we kind of extend this pattern a little bit, we should probably see that this guy goes down to 12, and then it kind of goes to a 10. So these first couple examples might have been relatively easy. There will be some examples, on your worksheet that I'm going to assign today that might be a little bit more difficult to eyeball. There is a mathematical process that kind of goes into this. So if I can't eyeball it, okay, so I can't see that the difference between 4 and 7 is 3. Okay, well, you're finding a common difference. Well, difference means subtraction in math. So what we can do is I'm going to take, 2 numbers that are next to each other. Let's just say this 4 and a 7. Okay, so I'm going to take that 7 and I'm going to subtract 4. I want to know what difference makes up the difference between them. I want to know what's in between those guys. Well, 7 minus 4 is 3, which is exactly what, our math and our experience with these numbers have told us to do, right? We can grab any kind of consecutive numbers in this sequence or this arrangement of values like this, right? So the second number that I see there, I'm going to subtract the first. Okay, 16 minus 13, again, gives us a common difference of a 3. Okay, so this also is going to help you with negative numbers. Okay, so there's a reason why I did the first number minus the second number. Again, these values are going down. Okay, and we need to remember if they're going down, we represent that with a negative value. Okay, so let me zoom in a little bit more. Okay, so if I take that second number, which is an 18, and I subtract 20, well, 18 minus 20 is a -2, so you're adding -2 there. So let's use that process for the next one. Again, maybe we can't eyeball how to get from -30 to -20. So I'm going to say -20 minus -30. Okay, so hopefully you have a calculator handy. Desmos can add, subtract numbers. Calculate 84 is a great app that we've kind of talked about in class before that gives you a graphing calculator. But if I take -20 and I'm subtracting a -30, that should be a +10. And you should notice that we go from a super small number way down in the negatives, and we're kind of gradually getting bigger. So notice my number is positive. So it looks like I'm adding 10 each and every single time. So as I'm adding 10, and we're the last or the 4th term here, right? Term 1, 2, 3, 4. Term 4 is a 0, which means term 5 should be 10. term 6 should be 20. And our last example, here's where I'm talking about there might not always be super easy to kind of eyeball, but again, you kind of have an algebraic approach here. If you want to find the difference, we'll subtract the numbers. So I'm going to take the first number I see here, or sorry, second number I see here. I'm going to subtract the first number that I see. Okay, so term 2 minus term 1, 5.2 minus 3.5 simplifies to be 1.7. So it looks like I'm consistently adding, right? It turned out to be a positive. Looks like I'm consistently adding that 1.7. And again, you don't have to do the first two terms. You know, just any two consecutive terms, just make sure you take that second term and you're subtracting the first. So if we're going to extend the pattern here, 8.6 plus 1.7 is what? 10.3? Which would make term 1, 2, 3, 4, 5. Term 6, 12. Is that right? Yeah. Okay. So this is how we can identify that arithmetic sequence. We have that consistent rate of change. We're adding or subtracting by the same number every single time, right? This last case that we talked about, if we find the difference between each and every single number, it should be that 1.7. Okay, the last example, again, if we look at every single number, the difference between them, we should have looked at we were adding 10. Okay, so that is the best way. That is what we're going to refer to as known as the arithmetic sequence. Now, this is part 1 of my video. Okay, the link below is going to show you part 2, and we're going to look at another sequence.